Hi friends, welcome to my channel. I hope everyone is doing well. Today we are going to solve another extremely popular coding interview question. It's on Leetcode 785 is graph bipartite. So this is a very popular medium complexity graph related coding problem. One of the questions that is asked by many companies many times. So make sure you watch this video until the end so you completely understand the logic, the approach as well as the solution how to solve this coding problem. So let's first go through the problem statement, then I'll show you some interesting examples. There is an undirected graph with n nodes where each node is numbered between 0 to n minus 1. You are given 2D array graph where graph u is an array of nodes that node u is adjacent to. Okay. More formally, for each v in graph U, there is an undirected edge between node U and node V. The graph has the following properties. There are no self edges. Graph U does not contain U. Okay. There are no parallel edges. Graph U does not contain duplicate values. Okay. If V is in graph U, then U is in graph V. The graph is undirected, right? So the edges will be from both sides, right? That's what undirected means. Okay. The graph may not be connected, meaning there may be two nodes U and V such that there is no path between them. A graph is bipartite. So this is very important. This is the definition of what a bipartite graph means. Okay, a graph is bipartite if the nodes can be partitioned into two independent sets A and B, such that every edge in graph connects a node in set A and a node in set B. Okay, this is the definition of what a bipartite graph is. Written true if and only if it is a bipartite graph. Okay, so just to show you one some interesting things about bipartite graph. So I'll show you one link. You can check it later. But this is a Wikipedia bipartite graph link. So it's mathematical explanation of what a bipartite graph is and with a couple of examples and its applications also. In mathematical field of graph theory, a bipartite graph, which is a bigraph, is a graph whose vertices can be divided into two disjoint and independent sets U and V. That is, every edge connects a vertex U to one in V, right? So the also equivalently a bipartite graph is a graph that does not contain any odd length cycles. Okay, so and this is very important, right? This is very interesting. The two sets U and V may be thought of as a coloring the graph with two colors, right? If one color of all nodes U blue and all nodes V in red color, each edge has endpoints of differing colors, right, as required in the graph coloring problem. Okay, so this is an interesting thing that we will also use when we are solving our problem. So let's understand what this graph coloring means quickly. So this is two examples of bipartite graph which is given here, right? So this is from here, guys. Okay, so what does this mean? So bipartite means that basically you will see that each node and its neighboring node have a distinct color, different color. So what does it mean? So each node, for example, one and its neighbor A, right? This is a neighbor, right? It has a different color. Its neighbor is E. E has a different color. So this is red, this is blue. Now A's neighbor is 3. It has a different color than A, right? This is blue, this is red. Very important, right? 3's neighbor is B, right? B has a different color than red. So this is red, this is blue. So this is very important, right? So you will see that this color, so it means that basically I can make a disjoint set. So this is one of my set, let's say U, and this is another of my set, let's say V, and they are disjoint. There is no color overlap here basically. So this is an example of a bipartite graph. Similarly, this is also example of a bipartite graph. Why? Because adjacent nodes right here, the neighboring nodes has a different color. So this is blue, red, blue, red, blue, red, and red here, right? Then again blue and red. So this is an example of a bipartite graph, guys. Okay, so I hope you understood the concept of what that color means here. So the colors of any adjacent node in the graph will be different basically, right? Then it's a bipartite graph. So let's quickly take a look at what the examples they have given us. So these are their examples, guys, okay, in the Leetcode. So you will see here that this is an example of a graph which is not bipartite. Why this graph is not bipartite? Because if I put a color here, for example, let's draw some colors, guys, so that you will understand this concept clearly. So I will draw color. So this is, let's say, pink, right? And let's say this one is a blue and blue, right? So if I do like this, then can I have all the neighbors as distinct colors? No, right? Why? Because this color is pink, right? So this is pink, its neighboring colors are distinct. This is distinct, yes, blue distinct, but what happens with this is not distinct, right? This is a neighbor of 0 and 2 are connected and they have same color, so this cannot be a bipartite graph or bigraph. Okay, so this is not an example of a bigraph, this is an example of a bigraph. Again, if I do the same thing, if I take two colors, let's say red color here and blue color here and blue color here, right? Now, is this graph a bipartite graph? Yes, this is a bipartite graph because its node and the neighboring nodes have always distinct colors. So 0 and neighbors are what? 1 and 3. They are distinct colors. Yes, this is red, this is blue. Okay. What about the 1? Are its neighbor distinct colors? Yes, because one's neighbor is 2, red color, and this is red color. So they are distinct colors basically, different than the neighbors basically, right? This is blue, so neighbor is red, this neighbor is red, so they are different colors. So I hope you are getting the point basically, right? So similarly, this is also example of a bigraphs that I have shown you, right? So this is an example where this is a bigraph, right? If so it means that I can disjointly basically create disjoint sets of nodes, right? So first set I can put here 0 and 2, right? 0 and 2 I can put, and I'll give one color to them which is red in this case, and in the second set I will put 1 and 3 and I'll give a blue color to them, right? So I can make two disjoint sets now, and in such a way that these neighbors are always having distinct color. So zeros neighbor are 1 and 3, they have color different than red. Yes. One's neighbor and 0 and 2, they are color different than blue. Yes, red, correct. Two's neighbors are 1 and 3, they have different colors than 2. Yes, it's blue and blue, correct. So it means that I can create two disjoint sets like this. So it means that this is a bigraph or bipartite graph basically, right? Bipartite graph. Okay. So I hope you understood the concept of a bipartite graph clearly with these examples. So we will, how we can solve this problem? We can solve this problem. We will use a BFS here, right? We can use a BFS here, which stands for breadth first search or breadth first traversal, and it uses queue, right? It uses queue. So how will it work? So I will start by giving a node 0 one color, right? Node 0 will have, I will first create a graph, right, from this information that is given to us, and then I'll start with 0 as the starting point. I'll give one color to that 0 node, right? So let's say I give a color 1 to that 0 node, for example, right? So I have given one color to that node and I add that 0 to my queue, right? This is the queue, right? This is the queue. And what how it will work in internally? So next time I'll remove 0 and I'll get its neighbors, so 1 and 3, right? 1 and 3. So what I will do, 1 and 3 I will, so every time I go to the neighbors I will toggle the color basically, right? So for 1 I will give another color which is, let's say, 0, and for 3 also I will give another color which is 0, let's say, right? 0. Okay. Next time when I remove 1, right, one's neighbor will be 2, so I will add 2 to this, right here, 2. Next time I'll add 2 here, and 2 I will give a next color, because I am going to go to the next level basically, right? Another level, another color. I will toggle the color basically, another, in the sense, toggle the color between 1 and 0. I'll give one color here basically, right? So you will see that now 0 and 2 has color 1, correct, which is one color, in the sense red color, and 1 and 3 I will get same color, right? if I actually come across a situation where my neighbor and my previous color is becoming same, then in that case I'll say that that is not a bipartite graph. But this is the case where I will not have that problem, so this is a bipartite graph. If I apply this logic on this one, then this one I'll give 0 color, color 1 to node 0, correct? So let's draw a queue here, right? So this is my queue, right? In the BFS, I'll first start with 0. I'll start giving color 1 to 0. Okay, so this is color. Okay guys, this is color, and this is node. This is node. Okay, this is node, and then I'll remove this 0. Once I remove 0, I will add what? I'll go to the next level. I'll add its neighbors. Neighbors are 1 and 3. So 1 and 3 are the neighbors. Okay, fine. I will add next color to 1 and 3. The color I will toggle between 1 and 0. So I'll give them color 0 here. Okay, fine. Now what will happen now? I will go to 1. I will add the color. I'll add 2 here, right? And for 2, when I process 2, what will happen? I will give color 1 to 2, right? Now you will see that the ones 0 and 2 are neighbors and having the same color basically, right? In the BFS you will notice that 0 and 2 will have same color and they are actually neighbors here, right? So actually 1 3 and 2 I have to give color 0 here, right? Color 0 I mean to say, right? Because zeros neighbors are 1 3 and 2, so I have to give color 0 here. Now when I process 1, then I will notice that 2 is again a neighbor and 2's color will be conflicting actually, right? Because 2 and when you process 1, one's neighbor is 2, right? One's neighbor is 2 and they have same color. One's color is also 0, 2's color will also be 0, which is not possible in the bipartite graph, right? Which is not possible in the bipartite graph. All the neighbors should have different color basically, right? So you see this example, here. So neighbors have different color. So one's neighbor is, this is red, this is blue, so this is red and red, right? So this is not, blue cannot be possible basically. Here is another example, right? So if this is blue, next cannot be blue. It is red, fine. This is blue, red, fine. This is blue, red, fine. Red, fine, right? This is red, then blue, fine. Then blue, then red, fine, right? So they cannot be having same color basically. That is the thing. Okay. I hope you understood this concept of BFS, how we can use that BFS concept here, right? And we can easily solve this graph problem. So let us go ahead, guys. I'll show you the code, then it will be more clear for you. So this is a very important problem. So is bipartite is what we are implementing. The graph is given to us here, right? Which is essentially a graph, a 2D array. Okay. So graph.length is n, which is number of edges there, right? And color is equal to n. I'll create one color array here, right? To give a color to each node, right? But those will be only 2 colors. We'll just keep toggling between colors for each level. Okay. First we will say that color, everything will be filled with -1, right? It means that nothing has been colored in the beginning, correct? You understood, right? -1, why? Because nothing is colored in the beginning. Okay, that's why. Now for I is equal to 0, I is less than n, I plus plus. So now we'll start iterating through the graph that is given to us here, right? And you will check if this color is not already given, uh, like if it is not -1, it means that you already colored that node. It means that you will continue in the for loop because you already have visited that node actually. You understood, right? You already have. So rather than creating another visited array, I am just going to use that color array only here, right? Because it's actually marking that we have actually visited once we put a color there, right? Okay, now let's say it's not visited, then I have to do a BFS for that node, correct? Now I'll create a queue which is a linked list of integers. I'll add ith node into the queue because I am processing a ith node basically, correct? I'll add a color to that ith node. In the beginning it will be 1. Okay, in the beginning it will be color 1. Okay, You understood, right? I'll start toggling between the colors 1 0 1 0 like this. But starting in the beginning, I have to start with 1. Okay. After that, I'll process. So this is the main point where our BFS starts now, right? So while queue is not empty, you will poll that node, right? Poll will do what? It will remove that node from the front of the queue basically, right? Once you get that node, you will find out its neighbors in the for loop, and you will keep processing the neighbors. If there is no color to the neighboring node, then you will give a color to the neighboring node, but you will toggle the color. This is very, very important. You will assign opposite color. So toggle means opposite 1 0 1 0 like this basically, correct? So color of neighbor is equal to color of node. If it is 1, then you will give 0. Otherwise, you will give 1, correct? So you have opposite color. You add that neighbor to the queue. Now this is very, 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 very important, guys. So if the color is not -1, it means that you already have a color given to that neighboring node. And if this color is equal to your current node color, you understood, right? If your color is equal to your current node color, it means that you are two neighboring nodes have same color. So there is a conflict, and it cannot be a bipartite graph like this basically, right? 0 has a pink color and its neighbor 2 also has a pink color. So this cannot be a bipartite graph, right? So in that case, you will immediately return false, because this is not a possible situation, right, for a bipartite one. Otherwise, you will keep looping in this BFS, and you will keep checking for each node whether you can actually this graph is a bipartite or not based on this constraint of colors. If you reach at the end, it means that this is a bipartite graph, so you will return true here. Okay, so this is it, guys. So I hope once you understand the concept of this BFS, then it's fine, right? It's easy, right? So you will start with color 1, and you will start giving different colors. So you give color 0 here. So let me remove all this so I can be clear here. So so what I mean to say, guys, is if you start with color 1 here, then when you process this node 0, what you will do, you will give color 0 here, you will give color 0 here, and you will give color 0 here. Okay, fine. Now next time when you process 1, you will notice that this is also a color 0, and this is also a color 0. They are neighbors, so this is not possible basically. So this cannot be a bipartite graph. Okay, so give it a run, make sure this code compiles and runs correctly against the test cases now. And as you can see here, the test cases are getting passed. We are getting false correct answer and true is correct answer. Submit this code now to the Leetcode. Make sure the code gets accepted by the Leetcode. And as you can see here, the code is successfully accepted. Let us try to do a resubmission. I'm not sure about these numbers. They are changing. So okay, so 31.57 percentile on the performance. This is a very clean approach to solve this coding problem. It's on Leetcode 785 is graph bipartite. Medium complexity, another extremely popular coding problem that we have solved by using logic of coloring and the logic of BFS here, guys, right? So make sure you go through this link. You will understand it even more and better way. But I explained this to you with all these details of BFS, how the BFS works, along with these nice examples that we have. So if you like these examples, and if these examples help you understand this bipartite nature of graphs, then please give a like for this video, subscribe to our channel now, and click on the bell notification icon button so you won't miss any interesting and upcoming videos like this one. On this channel, we explain how to solve different varieties of coding problems by using different data structures and algorithmic paradigms. We have more than 600 different solved coding problems, which are important problems. Their problems asked in interviews by Amazon, Apple, Microsoft, Google, Yahoo, and a lot of big companies. And those problems, we have compiled a very important playlist for you. The names of those playlists you should watch from our channel right away includes graphs, matrices, binary search trees, binary trees, problems solved by using important solving techniques such as binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices, and trees. The important data structures related playlist we have created, guys, for you include stacks, queues, priority queues, min heap, max heap, arrays, array list, linked list. So everything is here, guys. Share these videos with all your friends so they will also learn how to solve different coding problems. They can also get helped in their interview preparation process. If you are a Java consultant, we have very important videos for you that discusses frequently asked Java telephonic interview questions and how to answer them. So all types of important videos that are useful for your interview preparation are on this channel. So if this video helped you, then definitely give a like for this video, share this video as much as possible, and subscribe to our channel, and have a great day ahead. Thanks for watching this video.